Welcome to This Explainer. Today, we are completely demystifying Junos OS. We're going to take a Juniper router from an absolute blank slate right out of the box to a fully secure, manageable environment. Okay, let's dive into this.
Here's the concept to practice journey we're taking today. We'll start with a high-level look inside the Junos OS, then cover the commit model safety net, securing your first access, essential device configuration, and finally, managing interfaces and users.
All right, part 1, inside the Junos OS.
Let's kick things off by looking at what makes this operating system fundamentally different. Unlike older network operating systems that kind of just run as one massive, tangled program, Junos OS uses a highly modular architecture. You've got these primary software processes running in their own protected memory spaces. We've got MGD for management, chassis handling the hardware, and DCD for the interfaces. Think of these literally like watertight compartments on a ship. If one compartment takes on water, or, in this case, if one process encounters a bug or crashes, it doesn't sink the entire system. This strict separation of functions provides just incredible operational stability.
Now, if you're transitioning over from another vendor, learning a whole new OS might seem pretty daunting. And this brilliantly illustrates how simple the leap really is. This mapping guide directly translates your common Cisco iOS commands straight to their Junos OS equivalents. So, for example, instead of typing write memory, you simply type commit. Seeing them side by side like this really lowers the barrier to entry, right?
Another core aspect of this architecture is its innate security. Junos OS will absolutely not execute any binary without a registered fingerprint. Right out of the box, this built-in fingerprinting protects your system against unauthorized software and malicious activity that could otherwise compromise your entire network.
Moving on to part 2, the commit model safety net. Because let's be real, we all know that old dread of pressing enter and instantly losing access to your router.
Well, in Junos, that panic is totally a thing of the past thanks to the candidate configuration. It's essentially a draft configuration. Think of it exactly like writing a draft email. You can type, modify, review, and double-check for syntax errors all day long, but absolutely nothing changes on your live network until you intentionally hit send.
And in Junos OS, hitting send means using this single incredibly powerful command, commit. This is your ultimate safety net. When you type commit, the system first checks your draft for any syntax errors. If everything looks clean, it validates those changes, saves the active configuration as a file named juniper.conf.gz, and then immediately applies it.
Let's jump into part 3, securing your first access. All right, let's actually get hands-on here. Imagine you've literally just unboxed a brand new device. Because it isn't configured for the network yet at all, you have to connect physically via the console port to get that root-level access. Here are the literal first steps to get into the system. Step 1, connect to that console port. Step 2, log in with the username root. And hey, initially there is 0 password. Step 3, type CLI to launch the command line interface. And finally, step 4, type configure to enter configuration node. Now, what's really interesting about this slide is the physical change in the prompt to tell you exactly where you are. On the left side, when you type click, you'll notice the prompt ends in a greater than sign. That means you're in operational mode, where you can view device status. But over on the right, when you type configure, that prompt changes to a hash sign. That hash sign is your visual cue that you are now in configuration mode and you actually have the power to make changes.
But before you can actually save any of those changes, you absolutely must set a root password. The system enforces some strict rules here. It's got to be at least 6 characters long and contain at least 1 change of case or character class. And make no mistake, without setting this fundamental security measure first, Junos OS will strictly prevent you from committing any configurations whatsoever. It just won't let you do it.
When you're setting that root password, you actually have a few options. You can type a plain text password that the system will then encrypt for you, or you can provide a pre-encrypted password or an SSH public key string. If we contrast these options, it's pretty clear. Using pre-encrypted passwords or SSH keys is by far your best defense against man-in-the-middle attacks. Why? Because your raw password literally never crosses the network.
Okay, part 4, essential device configuration.
Now that the device is fully secured from a root access standpoint, we need to establish its unique identity on your network. To do that, we use these essential commands. You'll need to name the device using setSystemHostName, assign a domain with setSystemDomainName, and point it to your DNS with setSystemNameServer.
Let's move to and see how this builds into the overall configuration structure.
Notice how these basic identity settings actually look when they're arranged in the elegant Junos configuration hierarchy. Under the system block, your hostname, domain name, and name server are all just beautifully and neatly nested together. It really makes reading and auditing your configuration incredibly intuitive.
And that brings us to part 5, managing interfaces and users. So our identity's set, and now we need to shift our focus to giving authorized users access and setting up some really robust management routing. Let's pose a critical design question here. Why use a non-default VRF, or virtual routing and forwarding instance, for your management interface? The answer boils down to dedicated out-of-band management. By placing your management interface in its own dedicated routing instance, you ensure that your management traffic never, ever mixes with your production data traffic.
With that management interface safely isolated, we can start creating individual user accounts. To do this, you're going to need 3 things: a unique username of up to 64 characters, an access privilege or login class to define their permissions, and an authentication method like a password or an SSH key. So, the crucial point is that while you provide these specific details, the system actually goes ahead and automatically assigns the numeric user identifier, or UID, for you the moment you commit.
Let's actually look at a practical example of this. Here's the exact command used to load a secure SSH public key string for a user account named Boojum. By pulling the key file directly into the configuration like this, you guarantee a robust level of access control that totally bypasses the need for typed passwords. But hey, creating the user account isn't quite the final step. You have to remember that SSH, Telnet, and FTP are completely disabled by default in Junos OS. You must explicitly enable those remote access services, like SSH, in your configuration before anyone can actually log in over the network.
So let's recap where we are. Your device is now completely secure, your users are added with encrypted keys, and your dedicated management interface is live. You've successfully taken a blank slate and created a highly manageable, lockdown Juniper router. But that leaves us with a pretty provocative question for next time. Once this router is dropped into a live production network, how will your newly configured device handle a massive influx of dynamic routing protocol traffic? Well, that's where the real fun begins, and we'll be exploring all of that in our next explainer. Thanks so much for joining me today.